In a bold and ambitious announcement, scientists reveal the discovery that sent shockwaves through the scientific community, the identification of a new planet unlike anything known before. Known for its pioneering achievements, NASA has shown that the mysterious world is amazing not because of its size and location, but because it shows artificial light. This revelation raised a question that has tempted humanity for generations: are we on the verge of discovering the mysteries that will change our understanding of the world? Could this discovery reveal life on other planets? As we delve into NASA's amazing discoveries, we get closer to the truth about these amazing lights, which can truly define our place in the universe. In 2007, NASA launched the Dawn spacecraft on a mission to explore some of the most fascinating objects in the solar system. With 3 ion engines at the time, Dawn was revolutionary technology and could go on to uncover the mysteries of the asteroid belt. The first target was Vesta, the second largest asteroid in the belt, which took 14 months to complete the survey. The images and data provided by Dawn reveal Vesta's complex surface and diverse geology, revealing important information about its history and formation. But the best part of the mission began after Vesta. Dawn has discovered Ceres, the largest mass in the asteroid belt and a dwarf planet that has long puzzled scientists. Thanks to its ion engines, Dawn will be able to leave Vesta's orbit and determine its path to Ceres, a feat that traditional spacecraft cannot do. These engines, thanks to the gentle but constant thrust, will allow Dawn to travel far and enter a real orbit around Ceres, ready to reveal its secrets. Ceres was discovered in 1801 by Italian astronomer Giuseppe Piazzi and has been the subject of intense scientific interest ever since. As the largest object in the asteroid belt, with a diameter of 950 kilometers, Ceres has a unique composition that sets it apart from its rocky neighbors. Unlike most asteroids, which are mostly rock and metal, the comet Ceres has a more compact appearance, indicating that it may contain a lot of liquid ice. This has led to the idea that Ceres may hold clues to the early solar system and the processes that led to planet formation. When Dawn began sending back detailed images of Ceres, the scientific community was amazed by what they found. These images show a surface full of bright spots, especially in a large crater called a crater. These phases of the Moon, the subject of speculation before the arrival of Dawn, have always generated interest and controversy. What are these points? Could it be a sign of earthworks or something more remarkable? The Moon scenes in the Acater crater became one of the most spectacular discoveries of the Sahar mission. Before Dawn, the best images we had of Ceres were blurry, low-resolution ones taken by the Hubble Space Telescope. Little is known about this distant world, and the prospect of a closer look promises to reveal great secrets. As Dawn near Ceres, the images have improved in clarity, showing that the Moon's features are not a single object, but a collection of distinct areas. The scientific community is full of theories about their nature. Some thought it was a block of ice reflecting the sun, while others thought it was a deposit of minerals, perhaps salt, left behind by the receding water. The discovery of these bright spots suggests that Ceres may be more active than previously thought, and that geological activity is continuing. Ceres belongs in the asteroid belt not only because of its size, but because of its composition and potential for liquid ice. Unlike the typically rocky asteroids that populate the belt, Ceres has a more porous surface, with a mixture of water ice and hydrated minerals, including clays and carbonates. This unique composition has led scientists to speculate that Ceres could have once harbored liquid water, and might still contain pockets of brine beneath its surface. This possibility is further supported by the discovery of ammonia clays on Ceres, which suggests that the dwarf planet may have formed in a colder region of the solar system before migrating inward to its current location. The presence of ammonia, which lowers the freezing point of water, could support the existence of subsurface brines, liquid mixtures of water and salts that remain stable at lower temperatures. These findings not only enhance our understanding of Ceres but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. One of Ceres' most fascinating discoveries is evidence of cryovolcanism, a relatively rare geological process in which ice volcanoes, called cryovolcanoes, are formed with substances such as water, ammonia, or methane instead. For metal rock. On Ceres, ice volcanism is important in forming the surface, especially in places like a crater. Cryovolcanism on Ceres may work by allowing water filled with dissolved salts to reach the surface. When this salt water hits the vacuum of space, it rapidly condenses, leaving highly reflective salt deposits. These glowing remnants are among the mysterious places Dawn discovered, especially in a crater. The most famous of these places, called Cerealia Facula, has attracted a lot of attention because of the large amount of reflection and fog that can be seen every morning. These volcanoes are suspected to have originated from water jets, suggesting that volcanic eruptions on Ceres are still present or have recently occurred. As Dawn continues its mission, detailed images of Ceres begin to reveal a variety of surface features that tell the story of a complex and dynamic planet. The surface of Ceres is covered in craters, each bearing traces of ancient collisions that shaped the history of the dwarf planet. But Ceres' most unusual feature is the bright spots scattered across the surface, suggesting that ice may be a widespread feature on this frigid world. These light spots are not limited to one location, but can be found in many places on Ceres, each with their own unique characteristics. This wide distribution indicates that Ceres is far from a neutral body. However, this may be one of the most dynamic things in the asteroid belt, and the processes that continue to create its surface. The discovery of bright spots on Ceres has a profound impact on our understanding of the solar system. The possibility that Ceres still has water or salt water beneath the surface raises interesting questions about life. Although conditions on Ceres are far from those that would support life as we know it, its presence of water and strong geological activity make it a prime candidate for exploration. In addition, the discovery of cryovolcanism on Ceres will help our understanding of similar processes occurring on other icy bodies, in the solar system and beyond. Studying the volcanic eruptions on Ceres can provide insight into the Earth's history of other dwarf planets, moons, and even exoplanets with similar characteristics. Ceres' unique properties, its size, composition, and potential for water ice, make it a fascinating subject in science. Unlike most asteroids, which are composed mostly of rock and metal, Ceres is a comet-like object, consisting mostly of water ice mixed with rocky material. This leaves Ceres as a bridge between the rocky bodies of the inner solar system and the icy bodies of the outer solar system. The presence of water ice on Ceres also has implications for our understanding of the distribution of water in the early solar system. If Ceres formed in a colder region and migrated inward, it suggests that water-rich bodies may have been more common in the early solar system than previously thought. This, in turn, could have implications for the delivery of water to Earth and the other terrestrial planets, shedding light on one of the key questions in planetary science: how did Earth, and by extension life, acquire its water? The Dawn mission's exploration of Vesta and Ceres has provided a wealth of data that has transformed our understanding of these two bodies and their place in the solar system. The mission has revealed the complexity and diversity of the asteroid belt, showing that it is not merely a collection of rocky debris but a region rich with varied and dynamic worlds. Dawn's observations of Ceres, in particular, have challenged previous assumptions about the dwarf world, revealing a very complex and active world. The discovery of bright spots and loud volcanic noises on Ceres has opened up new avenues of research and raised questions that will occupy scientists for years to come. At the end of Dawn's mission, it left behind a legacy of discoveries that will continue to influence future missions and research. But the exploration of Ceres is far from over. The data collected by Dawn set the stage for future missions that could explore Ceres in more detail, possibly even landing on the surface to perform analysis in space. One of the main questions that remains is what Ceres' basement is like. Is there water or salt water below the surface, and if so, what are the implications for life? Future missions may use radar or other methods to probe below the surface, looking for signs of liquid water and other materials that could provide clues to Ceres' geological history. The discovery of bright spots and the possibility of salt water beneath the surface of Ceres put it at the forefront of the search for extraterrestrial life. Although the conditions on Ceres may not support life as we know it, the presence of water and geological activity make astrobiological research very interesting. The study of Ceres could also provide insights into the conditions that might exist on other icy bodies, both within our solar system and beyond. If Ceres can host water and geological activity, it raises the possibility that similar processes could be occurring on other dwarf planets, moons, and even exoplanets that share similar characteristics. Ceres remains one of the most enigmatic and fascinating objects in our solar system. The discoveries made by the Dawn mission have revealed a world that is far more complex and dynamic than previously thought, with bright spots that hint at ongoing geological processes and a surface composition that suggests the presence of water. As we continue to explore Ceres and other similar bodies, we are likely to uncover even more surprises that will challenge our understanding of the solar system and the processes that shaped it. The story of Ceres is far from over, and as we continue to learn more about this mysterious dwarf planet, we may find that it holds the key to answering some of the most important questions about our place in the universe. World.